All right, in this video we're going to work a couple of probability problems and look at how to use a table of information to find some probabilities. In this one, respondents to a survey indicated the following categorizations pertaining to attendance at religious services. There were a total of 2,788 respondents. So that is our total, and that's important to know when we find probabilities. And you can see here we have a number of categories: never, less than once a year, et cetera, et cetera. And then we have a don't know the answer group with 21 responses in that group. These are mutually exclusive groups. People had to choose one. If they had no idea, then they had to choose this one. But they can't be in more than one group. So we're going to answer several questions about this using the information from the table. Find the probability that a chosen person attends religious services with the indicated frequency in parts A through C below. So first of all, more than once a week. So we're going to find more than once a week, which is right here. And the number of people who gave that response was 222 out of the 2,788 who responded. And when we do that on the calculator, we get 0.0796, and when we round off, we cut it off after the 6. The number after the 6 is a 2, so we would just round this down to the 6. So 0.0796, this was just a little under 8% of the people who gave that response. Several times a year. If we look for that, that's right here. That's 353. The same denominator because we're looking out of the same total group of people. And when we do that on the calculator, we get 0.1266 when we round to 4 decimal places. And then our last question asks once a month or more frequently. So once a month is here, and more frequently are the responses over here, except for don't know the answer. That wouldn't be a frequency at all. But once a month or more frequently is going to include once a month, 2 to 3 times a month, nearly every week, more than once a week. So all of those are going to go into our numerator, and our denominator is still going to be the 2,788. So we have the 133 who said once a month, then the 253 for 2 to 3 times a month, 165 for nearly every week, 478 for every week, and 222 for more than once a week. And we add those up and divide by 2,788, and we get 0.4487. That's the probability that someone attended once a month or more frequently. In the next question, the second one we have a table that lists the number of hours people worked in the last week based on their classification as full-time or part-time workers. And we're going to use the table to find the probability that someone is classified as a full-time worker. And then I've added a couple of questions on here since we've already got the table of values here. I wanted to go ahead and do a couple more examples using the information and data that we have here. So first of all, the probability that a person is classified as a full-time worker. Well, again, we need the total for our denominator, and the total is listed here. It's the sum of these totals, but it's also the sum of all these numbers. So those both have to add up to the same thing, and it's 1,613. And the probability that a person is classified as a full-time worker is all of these people. So 1,298 people out of the 1,613. And when we do that on the calculator, we get 0.8047, and we round that to 4 places. We cut off after the 7. Then the questions that I've added here, find the probability that someone is a full-time worker and worked 40 to 49 hours in the last week. Well, that's going to be where full-time worker and 40 to 49 hours last week intersect. So that's going to be this group right here, which is 699 people were full-time workers and said they worked 40 to 49 hours in the past week. So the 699 is our numerator, and our denominator is still 1,613. So when we calculate that, we get 0.4333. We get a bunch of threes. But if we round to 4 decimal places, the last 3 here will become a 4 because the number beside it is a 5. So 0.4334 is the probability that a person is a full-time worker and also worked 40 to 49 hours in the last week. Now, the last example we're going to use this table to answer is find the probability that a person is a part-time worker or worked 20 to 29 hours in the last week. The and was the intersection of the two things we were talking about, full-time worker and 40 to 49 hours per week. So it was only the 699 where those two intersected. For the or, we need the total, but we have to remember that some people are counted in both of these categories. So we're going to look at that. So first of all, we're going to look at part-time worker. The total number of part-time workers is 315 right here. So we're going to put that in. And then we also need the number of workers that worked 20 to 29 hours a week. Well, if we look right here, that's 143. But then if we look closely, these 83 people are counted in this total because part-time workers are all of these numbers added up. So these 83 people have been counted in this total, but they've also been counted in this column of 20 to 29 hours last week. So they are included in this number and in this number. So basically, if we put those two numbers there, we've double counted those 83 people. So we're going to subtract out 83. We don't want to eliminate the people altogether, but we just want to eliminate the double counting. So we subtract that value out, and then they'll only be in this total once. And so we have 315 plus 143 minus the 83 who were both, and then still divided by 1,613, and we get, on that one, we're going to get 315 plus 143 minus 83, enter, divided by 1613, and we get 0.232, and again, we're going to round this up to a 5, this 4, because its neighbor is an 8, and that will give us a probability of 0.2325.